Hello, everybody, and welcome to day one notes. So this is actually the notes that go along with our standard assignment. We will do a little bit of review of what we did last time, and then we are adding exponents to these radicals. So today we're going to be simplifying radical simplifying radical expressions rather, and let's just get into it. So perfect squares. Perfect squares, if you look at this, you got 1 times 1, which is 1. You got 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, and 11 times 11 is 121, and then 12 times 12 is 144. So, perfect squares, it's not going to really help you here, but it's just some information. Exponents, perfect square exponents, so we have x to the second, x to the fourth, x to the sixth. Next, we're going to have x to the eighth, and x to the 10th. Meaning that exponents must be even to be perfect squares. They're not just, numbers like, 25 and 8. Obviously, 8 is not a perfect square, but we'll get into it later. X to the 8th power is actually a perfect square. So anyway, we already talked about numbers last time. What I would recommend is we are doing exact solutions, no decimal approximations. We shouldn't really need a calculator for this unit. So let's just start by the square root of 100. Well, the square root of 100 is 10. So we're actually, taking out the perfect squares, kind of like what we did last time. And we'll break some of these numbers down later. Square root of 49, hey, it's just 7. Okay, now let's get into y to the 10th. Square root of y to the 10th. This problem right here. Well, what does it simplify to? Well, let's just recall last time when we did a factor tree. Say we did a factor tree of 8, right? And we had radical 8. And we needed to break that down to 2 and 4. And then we have 2 and 2. Circle pairs that come out, box the one that stays in, and that is a 2. Therefore, this square root of 8 simplified is actually 2, because they come out and make 1, square root 2. Great. Well, you kind of do the same thing with exponents. So y to the 10th, what is that? Well, let's break it down. So square root of y to the 10th, I can write it out like this. I'm going to make a big square. Y times y times y times y times y times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are all multiplication. Stand that out a little bit. So again, what I'm going to do is I'm going to circle pairs to come out. Got a pair right there. Got a pair right there. Got a pair right there. Got a pair right here. Got a pair right there. And how many pairs do I have? Well, I have 1, 2, 3, 4, 5. These are going to come out. So square root of y to the 10th is y5. Same thing with this. I have an a and an a here. Circle pairs that come out. Square root of a squared is a. So let's go into a little bit more challenging problems here. We already kind of went over numbers. So now we're going to actually mix the numbers and the exponents, variables together. The variables with the exponents together. So let's look at number 9. Okay, what you first need to start down is breaking down the 49. And if you're not well versed in this, you do not know 49 is a perfect square, but by doing a factor tree, you find out it's a perfect square. So 7's going to come out. What you're going to know is if these are even, or even if they're odd, what you're going to do is divide by 2. That's basically what you're doing. You're grouping them by 2. So this becomes 7a to the 2nd, b to the 6th. And that is a simplified version of that radical. All perfect squares there. So now let's go into some more challenging problems here. And let's actually look at number 9. Okay, we're going to do 2 of these problems, maybe 3. I'm not 100% sure, but we're going to do a few of them. So I'm actually going to rewrite this up here so I have a little bit of room to operate. So I'm going to I need to simplify this, okay? The problem is, hey, it's asking me to simplify the square root of 27, a to the 11th, b to the 7th. So what I'm going to start doing is breaking down the 27 because I need to break the number down first. It's always recommended to do, break the number down first. And I said if it's even, just divide by 2. Well, you're going to notice 27 is not even. But I can divide it by 3, a prime factor of 3. I'm dividing by prime factors here. It makes it easier if you just try to divide each term by a prime factor. Okay, 3 is prime, so I'm going to divide by 3. Then I have 9. I'm going to go 9 and 3 and 3. Circle pairs that come out, box the ones that stay in. So far, I have, and I'm going to just write it above it, I have 3 radical 3. Now I do have letters, I do have variables here raised to the exponent. Remember, you're going to divide these by 2. Okay, well, what's 11 divided by 2? Well, you can't really divide 11 by 2 evenly, but I will say there is at least 5 groups right in there. But one's going to be left over. So if it is a odd exponent, you're always going to have 1 left on the inside and then just divide to the closest even number, right? 7, I'll take you think, divide by 2, right? So it's going to be, oh, I made this a little close, so I'm actually going to move it over. And I'm going to have b to the, what's 7 divided by 2? Can't do it, so let's go down to 6. 6 divided by 2 is 3. There's going to be 1 left over. And that is your final answer. All right, let's go ahead and do number 10, and then we will do, we'll probably do one more after that. Maybe 20. 20 looks a little challenging. It's just big numbers, really, but it's not bad. So let's do 10. I might change this color. I'm going to probably do it up here so I have some room. First, always try to break down the number. Okay, I have 2 and 16, 2 and 8, 2 and 4, 2 and 2. Circle pairs that come out. All right, great. What just happened here is I'm going to have a 2 come out to the outside, another 2 come out to the outside. So that's going to make 4. Remember, we're multiplying. I'm going to have this radical in here with a 2 on the inside because that's a boxed thing. A to the 7th, okay, I'm going to divide it by 2, which is going to be 3 with 1 remaining. And then b to the 4th, well, it's actually a perfect square, right? And this is your final answer. All right, on number 14, I'm going to show you a little bit different way to do it. I recommend this way, okay? It's the beginner's way of these factor trees. Break them down by prime factors, circle pairs that come out, box the ones that stay in. Please do that. That is a number 1 way, but there is a quicker way to do the numbers, and I'm going to show you that on number 14. Okay, so let's just do number 14 real quick. I'm going to go ahead and hopefully try to do something like this. Okay, give me a little room to work here. So I'm going to do number 14. I'm going to show you a different way to do this. I'm actually going to just take out perfect squares. So I do not recommend this. If you're just trying to get a group of this, please break it down by prime factors. It is the best way to do it. But for somebody that's a little bit more advanced, I am going to show you a different way. So let's do it. So start by breaking down the number. Okay, and then this time when I do my factor tree, what I'm going to do is I am not going to break it down by prime factors. I'm going to try to pull out perfect squares. Okay, what I mean by that is 12 is 4 times 3. So please disregard this if you are just trying to get the hang of it. I do recommend this way, right? But I would not be a math teacher if I didn't show you how to pull out perfect squares. Okay, what you're going to notice here is 4 is actually a perfect square. Okay, didn't know if you knew that, but it is. And 4 is 2 times 2. So far the number is going to simplify to 2, 3. Okay, because I'm going to pull out, what is 4? Well, 4 is 2 times 2, circle pairs that come out, voila. I got a 2 on the outside, right? So I'm pulling up perfect squares. All right, now I'm going to divide x to the 20 by 2, which is x to the 10th, and I'm going to divide y to the 8th by 2, which is y to the 4th. Nothing left on the inside. This is your final answer. Bye. You need to do all the problems in the assignment, the evens and the odds. Thanks. Bye.